Hello. In this work, we are going to talk about next generation networking and edge computing for mixed reality systems. This is a joint work between Susmit Shannigrahi at Tennessee Tech, Spyridon Masterakis at University of Omaha, and Francisco Ortega at Colorado State. So, augmented reality has come a long way in recent years. It is being used in various domains, education, construction, and many others. Companies, they're creating more advanced hardware like the Magic Leap 1 headset, Microsoft HoloLens 2, and many more. AR enables users to seamlessly integrate their physical world with the virtual world. And this is more relevant with the recent situation where all the work is being done remotely. And we think having a good networking framework for ARVR research could change the problems we have while working remotely and trying to do things in the augmented reality scenarios. So for next generation AI research, there are three main components. The first one is better hardware. The second one is better software and processing frameworks. And the third one is low latency network. The first two, they have been explored quite a bit. The last one is the least explored and is the goal of our work. So if you look at how AR/VR communities or the applications work, there is a hardware at the user side that captures input. It might be a video from the user surrounding and then sends it to a remote processing side. The processing is increasingly being hosted in the cloud. Once the data is processed, it may be annotated, transcribed, and then sent it back to the user device for rendering. So if you talk to the AR/VR researchers, what do they expect? They would tell you that they expect low latency. But the way the word low latency is used, it's pretty loose. It can be anywhere from 10 milliseconds to 1 second, depending on who you ask and what that researcher is working on. For interactive applications, there needs to be below 50 milliseconds. And in some cases, it could be below 10 milliseconds. If it goes above it, then the user starts to become uncomfortable and sometimes may become nauseated. Is latency the only networking challenge that the community face? We don't know. So to better understand what the ACI researchers want, we created a preliminary survey. We had and then distributed it over AR/VR mailing lists. We had 14 responses when this paper was published. And these were from prominent researchers in the AR/VR community and had a significant breadth of use cases. There were immersive education, social VR, VR chat rooms, business to business and consumer market research, and many others. What we found out is the latency expectations. On average, they are less than 50 milliseconds. Some are as low as 10 milliseconds. The maximum that we found in the response was about 200 milliseconds with quality degradation. But what are the other expectations from the network? One big thing that came up was the quality of service guarantees. They wanted to have dedicated bandwidth, low packet loss, but not if that means higher latency, and then low jitter. The bandwidth requirement was usually pretty low, less than 1 gigabits per second, with very occasional high bandwidth requirement, but none were hundreds of gigabits per second. The other observations we found in the survey was qualitative observations. People noted that the cloud services are not consistent with their QoS offerings. Sometimes there would be low latency followed by a very high latency that cannot really work very well for the use cases. So to work around that problem, researchers started to create their own processing servers in the local network and deploy them on some machines. Obviously, these machines did not have as much processing power as the cloud platforms have, but this is how they work around the latency problem in the ARVR community. There are multiple research gaps that we identified. The researchers said that they're using local computation, but they haven't really considered using edge computing for their use cases. They also pointed out that sometimes the processing power of the cloud is useful, but there is no way that currently we can have an edge and cloud hybrid model. So that got us thinking about how do we create such a hybrid platform that can reduce latency and then improve quality of service. So instead of just relying on the survey, we also decided to create our own applications to try it out. So the first application was a virtual robot from multiple components, assembled from multiple components using AR. For these experiments, we used Microsoft HoloLens 1, and there are two graduate students who are assembling this robot with augmented reality libraries. We used Microsoft Azure spatial markers and the photon engine. So the spatial markers, they allow you to move things in augmented reality space. For example, in this picture, the hand is being moved that is controlled by a spatial marker. The cloud could process this application both with and without the photon engine. What we found is that the latency fluctuated between 250 to 500 milliseconds. If we used photon sync, that made it even worse. Note that the target latency for this application was about 50 milliseconds. The Azure markers are not fast enough, obviously. So we deployed in-house markers in the local network that reduced the latency to about 2 to 4 milliseconds. The second application that we created was a streaming application. So we took a depth sensing camera, captured images through it at 30 frames per second, and then we sent it to a remote processing site where each gesture is processed and then sent back to the device. So we had 4 remote servers. The device was at CSU, and the remote services were at Denver, Sacramento, and LBL, Berkeley National Lab. And note that we do not include the processing time in this calculation. This is the networking time. So you have your transmission delay and then the propagation delay. Only the latency calculation is given in this figure. There's no application processing time. Note that just like the other application, the latency is in the range of 200 to 300 milliseconds, which is way more than what this application could tolerate. And if we used any other cloud platforms, we think the latency would be as bad. Okay, so now we know the problem. What is the solution for these high latency problems? So we create a framework called LLRIS that works as a hybrid framework for both cloud and edge computing platforms. So it has multiple functionality such as dynamic edge service and resource discovery, edge service invocation and task offloading, computation reuse and mobility, and then finally the edge cloud hybrid model. The way it works is that for this we use information-centric networking. We take the computation from the device sends it into the network with a service description. For example, here it could be image annotation with a deadline that could be 500 milliseconds. And you can optionally also specify other parameters. For example, the amount of RAM required, the number of CPUs required, and so on. So once the discovery interest goes out into the network, it brings back some sort of data saying that what kind of services are available in the edge, at the edge, and in the cloud. So if you look at the full architecture, this is what happens. So at the bottom, you have the device side where you have the ARIVR devices. They're connected to an NDN network using either Wi-Fi or 5G or some other connectivity. The devices discover the services that are being offered by the edge servers and the cloud servers. It sends out discover interest, discover the services, and then offloads the data into the network. The edge servers look at the computation request, decide whether they can complete that request within that given timeline. If they can, and if they have enough resources for that, they try to execute that task. If they find that they don't have enough resources, or the deadline is far in the future, they can choose to send it to the cloud servers. And all this happens transparently to the user, so they can simply offload the task into the network, and then when the computation is done, they can get the data back without having to worry about whether their services are in the local network, in the edge, or at the cloud. Note that this is a preliminary architecture where we are working on extending it. So what are the next steps for this work? We plan to extend the survey to include more responses and better understand what are the things that are going on in the ARIVR community and what their expectations are in terms of the network services. We are working on prototyping an edge cloud hybrid architecture that we just talked about. And then once we have it, we want to take actual use cases and import that into the framework and see how our framework can improve the network responses. Okay, so to conclude, the AR technologies can be transformative in many domains. The biggest problem the AR community has is the network latency. Even with the latest hardware and cloud platforms, we explored these problems through a survey and 2 pilot applications. We found that latency is a problem. The latency that's offered by the current networks are orders of magnitude more than what can be tolerated. And then we present an initial architecture for LLRIS, a framework that combines the edge and cloud computing platforms. Thank you. And if you have any questions, please feel free to email me at Shannigrahi at tntech.edu. Thank you.